All right, question 7 is asking us to compute the triple integral of 1 over the quantity x squared plus y squared plus z squared to the 3/2 power over the region E, where E is the region in the first octant bounded by the two spheres of radius 1 and 2 centered at the origin. So in other words, we're looking at this region between our blue sphere here of radius 1 and our green sphere here of radius 2 in the first octant. So let's first describe the region in spherical coordinates, and then we'll go ahead and compute the integral. So to describe the region, let's go ahead and let the radial distance rho vary first. So think about starting here at the origin and then moving radially outward. We're first going to intercept the blue sphere when rho is 1, and that's where we'll enter the region. And then we're going to move radially outward and then intercept the green sphere where rho is 2, and then we're going to exit out of the region. Okay, so our bounds on rho are from 1 to 2. And then for the bounds on phi, well, we're going to have to vary from 0 when we're up here along the positive z-axis out to pi over 2 when we're here in the xy plane. So we have to vary for from 0 out to pi over 2. And then lastly for theta, since we're looking at a region just in the first octant, theta is going to have to vary from 0 up to pi over 2. And so these are our bounds on theta. All right, so now for our integral, well, our differential volume element dV, as we derived in the last video, we saw that this is equal to rho squared sine phi, and then d rho d phi d theta. So I'll go ahead and put in our rho squared sine phi term, and then for d rho, we're letting rho vary from 1 to 2, and then for d phi, we're letting phi vary from 0 to pi over 2, and then for d theta, we're letting theta vary from 0 to pi over 2. All right. And then downstairs, well, we see this x squared plus y squared plus z squared to the 3/2, and 2 videos ago, x squared plus y squared plus z squared in spherical we saw was simply equal to rho squared. So this is just going to be rho squared raised to the 3/2 power. All right, so now that expression is just going to be rho cubed. And then I'm going to have a rho squared over rho cubed, so I'm just going to get a 1 over rho, which is quite nice. So now we're looking at this. So I have a 1 over rho. I have the sine of phi, and then I have d rho d phi d theta. Okay, not too bad. Now notice for the integrand, I have a 1 over rho times a sine phi. So I have a product of something that depends only on the variable rho, and then something that depends only on the variable phi. And then all of that's going to be constant with respect to theta. So in fact here I can go ahead and split this up as follows. The integral from 0 to pi over 2 d theta. Then I'm going to have the integral from 0 to pi over 2 of sine phi. And then the integral from 1 to 2 of d rho over rho. Nice. Okay, so now what are we going to get? We're going to get pi over 2 from the first integral. This is going to give us minus cos phi, as we let phi go from 0 to pi over 2. And then this is going to be the log of rho, and we're letting rho go from 1 to 2. So we get, well, plugging in pi over 2 for phi, that's going to give us cos of pi over 2, which is 0. Plugging 0 in is going to give us a negative 1, but it's being subtracted, so we're going to get a minus 1. So we'll get pi over 2 times 1. And here I'm just going to get a log 2. Plugging 1 in is going to give me the log of 1, which is 0. And so when all is said and done, I have pi over 2 times the log of 2. All right, not too bad. Thanks very much.